Okay, 6.2, graphing absolute value functions. So we've talked a little bit about absolute value already when we talked about quadratics, because every time we graphed a quadratic, I said make sure you make it U-shaped. Because if you don't make it U-shaped, then it's pointed, and if it's pointed, then it's absolute value. And I said, I kept saying, well, I'll show you that later. Well, now it's later. Now we're going to deal with that. Okay, so absolute value, you've seen these before, because we've solved absolute value equations. So they have the two bars. If it doesn't have the two bars, then it's not absolute value. So they can have stuff inside and outside of the bars, but they have to have the two bars to be absolute value. So some non-examples, things that are not absolute value. If it has an x squared, we've talked about, we know that's quadratic. And if it just has x and y with no power, then we know it's linear. Okay. And then as far as the graph's concerned, it's a V shape. It can open up, or it can open down, just like with quadratic. If the number in front is positive, it's going to open up. If it's negative, like this one here, it's going to open down. Okay. But if it's rounded, then it's not absolute value, then it's quadratic. And this, of course, is linear. Okay, straight line, it's linear. Okay. So it has a vertex similar to a parabola. So it comes to a point, one spot where it changes direction. But it increases at a constant rate and at a squared factor. So quadratics don't go up at a constant rate. If you look over here, this is an example of a quadratic. And from here it's changing 2, then it's changing 2, but then it's changing 6. Okay? Over here, if we look at this one, it has a vertex. I can still see the vertex. See that right there? That's the vertex because I have a 1 on the other side, I have a 2 here, and if I did another 1 over here, I'd have a 2 here. I have the symmetry. Okay, so it has that pattern, just like this one has the symmetry, 2, 0, 2, 8. It's got symmetry. And I can see my vertex, but this one changes at a constant rate. From 2 to 1 is 1, changing 1, changing 1, changing 1. Okay, increasing 1. Here to here. And then increasing 1 from the vertex. Increasing 1. Here we can't actually see the vertex, but we can see the symmetry. What that means is the vertex is between these two numbers. So my vertex is in here somewhere. But once again, from that point, we're going up 2 on the other side. This is plus 2, this is plus 2, so they're the same, even from here to here. Okay, these are the same, you're adding 2. So that's how I know that it's absolute value. It's the same, the rate of change does not change, it's constant. Just like with linear. Linear has a constant rate of change. Because here we're going up 2, here we're going up 2, here we're going up 2, so that means that this is linear. And this is changing 1. And then this one we talked about it being quadratic. Okay, the reason that they're constant, if you look here, these are really just two straight rays, almost like lines, and our lines have constant rate of change. So absolute value has a constant rate of change. It has to go up or down by the same amount from the vertex. Alright, let's look at an example. This one right here, we want to complete the table to graph it. So let's try plugging in a point. If I put in -2, the absolute value of -2 is +2, plus 3 is 5. If I put in 0, 0 plus 3 is 3. If I put in 2, the absolute value of 2 is 2, plus 3 is 5. Put in 4, 4 plus 3 is 7. And 6 plus 3 is 9. Alright, now I have lots of points to graph, and I could make a table with any x values that I wanted. And so I'm going to graph it, negative 2, 5. Zero, 3. And we can tell it's a vertex because then our pattern repeats. So it still has symmetry. 4, 7. And 5, 6, 9. Move here. So it looks like this, but remember, that it has that symmetry and it goes on forever, so really it comes up on this side too. Just the same. Alright. And we'll start talking about transformations as we go on. If there's a number in front, that's going to determine if it opens up or down. So since this is positive, it opens up. And then the number in back, with the plus 3, well, look, this is shifted up 3. It's up 3 from 0, 0, from the origin, from what we call the parent function. Okay, let's look at one more. So here we have y equals negative the absolute value of x minus 4. We put in 2. 2 minus 4 is negative 2. The absolute value of that is 2. But then there's a negative on the outside, so it's negative 2. 3 minus 4 is negative 1. The absolute value is 1. So negative 1 because of the negative outside. 4 minus 4 is 0. 5 minus 4 is 1. And there's a negative outside, so it's like times negative 1. 6 minus 4 is 2. And then the negative outside makes it negative 2. So notice there's a negative here, so this is going to be facing the other direction. So let's see if we can graph this. So we have 2, negative 2. 3, negative 1. 4, 0. 5, negative 1. And 6, negative 2. So it's going to go like this. And notice the negative 4 in here made it shift over 4. The negative in front made it flip over upside down. So we'll keep talking about transformations and looking at the different effects the different parts of it have. But really, if you can make a table, you can graph any of these. Alright, get started on your practice and let me know if you need any help.